Afghanistan, mid-1980s, Kunar province. A gorge above the Jalalabad-Asadabad road. A group of mujahideen in cover are observing a Soviet convoy. Below, APCs crawl along the broken asphalt. Helicopters circle above the mountains. The militants are waiting for the right moment for an ambush. Suddenly, the air is torn by a sound they had never heard on Earth. The screech of a turbojet engine, like a fighter jet taking off, but there is no plane in the sky. The sound is coming from the road. Something strange is moving along the highway. 40 tons of steel on tracks. A giant nozzle, almost a meter in diameter, protrudes above the hull. The screech intensifies. The ground shakes. The driver brings the engine up to operating speed. A blazing stream of gases erupts from the nozzle with a roar. An explosion occurs in front of the vehicle. The asphalt shatters into pieces. Stones fly like shrapnel. Dust rises in a 20-meter column. The roar is amplified many times by the echo from the rocks. The mujahideen froze. The senior man among them had fought for 10 years, seen Soviet tanks, BMPs, artillery, helicopters, but had never seen anything like this. The machine slowly crawls forward. The giant nozzle is aimed at the road like a cannon. A fiery, dusty vortex completely envelops it. The ground explodes in front of the tracks. The temperature is so high that the air shimmers with heat haze. The turbine's screech is audible for 3 kilometers. A fighter next to the senior man whispers a prayer. Another ran to the commander with a report. The third simply stares with his mouth open. For the partisans, it looked like a doomsday weapon. An hour later, reports were coming in through all the mujahideen communication channels. The Russians are testing a new weapon, a tank with a huge cannon that scorches the earth. A monster that roars like a djinn. The asphalt melts, stones fly, black dust rises. Western intelligence services intercept the radio communications. Analysts are bewildered. What kind of machine did the agents see? A thermal cannon? A plasma weapon? A new type of flamethrower? This monster had a name, Progrev-T, a single prototype. A VK-1 turbojet engine from a MiG-15 on a T-54 tank chassis. Thrust, 2,700 kilogram force. Exhaust temperature, 900 degrees. Fuel consumption, 3 tons of kerosene per hour. But to understand where this experiment came from, we need to go back 25 years to Moscow, to the height of the Cold War, when someone in the General Staff uttered a phrase that changed everything. On October 25, 1961, the Soviet Union and the United States were balancing on the brink of nuclear conflict. The Cuban Missile Crisis would shake the world a year later. But even now, the military on both sides are preparing for a war that could begin at any moment. Problem number 1, anti-tank mines. NATO is saturating Europe with minefields. Hundreds of thousands of anti-tank mines are buried along the proposed routes of attack of the Warsaw Pact. Standard mine-clearing methods are slow and dangerous. Roller mine plows are blown up. Sappers die. The offensive will stall on the minefields. The Soviet military needs a radical solution, something fast, effective, capable of clearing wide passages. And then, someone in the General Staff proposed a crazy idea. What if we used the power of a jet engine? The turbojet stream at the outlet has a temperature of several hundred degrees and a speed of hundreds of meters per second. The pressure is phenomenal. Such a stream should blow away the top layer of soil along with the mines, or detonate them by heating, or at least expose them for subsequent neutralization. The idea seemed brilliant. There were plenty of aircraft engines in the USSR. Decommissioned MiGs and other fighters were sent to scrap metal yards in tons, along with tank chassis. Combining one with the other was technically possible. On October 25, 1961, a decree was issued on the creation of a turbojet minesweeper. The development was entrusted to the Omsk OKB-174. Chief Designer, Alexey Andreyevich Morov. Task: to create a machine capable of sweeping mines using a gas dynamic method. Basis: T-55 tank chassis. Engines: two R-11 F-300 turbojet engines from the MiG-21 fighter. The project received the designation Object 604, alternative name TMT, Turbojet Minesweeper. The concept looked fantastic. Two engines with a total thrust of 5,000 kilogram force. The nozzles were directed forward and downward at an angle. The gas stream hits the road surface in front of the vehicle. The soil explodes. Mines are blown away or detonate. The tank drives along the cleared strip. 1962, a prototype was built. Combat weight 37 tons. The mine clearing width is 4 meters. Speed 3 to 4 kilometers per hour. Crew of 3 in a hermetically sealed cabin. Fuel supply for 2 hours of operation. Fourth quarter 1963, state trials. The spectacle was phenomenal. 2 jet engines roaring at full power. The ground shakes from vibration. A scorching stream of gases slams into the test range. Explosions of soil, clouds of dust. Training mines fly out of the ground like corks. Some detonate from the temperature. Military observers are delighted. The mine clearing width surpasses all existing systems. High reliability of mine detection. The psychological effect is stunning. The enemy will hear this machine from kilometers away and will be terrified. But reality quickly put everything in its place. Fuel consumption is catastrophic. The tanks are emptied in 2 hours. The noise is so loud that the crew goes deaf even in the hermetically sealed cabin. Dust penetrates everywhere. The filters clog instantly. The engines operate in abnormal conditions.
It operates at ground level instead of in high-altitude, rarefied air. The resource is dwindling before our eyes. The terrain limitations are devastating. It only works on hard, flat surfaces. On dirt roads, it explodes into the ground. On uneven surfaces, the jet misses its target. It's completely useless in mud and snow. The result was a machine for ideal conditions, which don't exist in war. The military calculated the economics. 1 hour of operation of Object 604 costs as much as a week of operation of a conventional roller mine trawl. Maintenance is many times more complex, reliability is lower, versatility is non-existent, and combat value is questionable. The project was closed down. Quietly, without scandal. The prototype was sent to storage, and the documentation was classified. The designers switched to other developments. The idea died. Or so it seemed. 20 years passed. The Afghan war turned into a bloody quagmire. Kunar province became one of the most dangerous zones. The Jalalabad-Asadabad highway is only 15 kilometers long, but these 15 kilometers are controlled by 6,000 militants. The Mujahideen destroy the road with water from irrigation ditches. In 2 days, instead of asphalt, a 10-meter wide washout gapes open. Under the rubble of stones and mud are mines, dozens, hundreds of mines. Sappers clear the mines meter by meter, dying one after another. Convoys get stuck, supplies don't get through. Garrisons are left without supplies. An urgent solution is needed. And someone in Moscow remembered the old blueprints from 20 years ago. Object 604 failed, but maybe a simplified version will work. 1 engine instead of 2, a cheaper base for a specific task in specific conditions. The decision was made quickly. Build an experimental prototype, test it in real combat conditions. If it works, put it into series production. If not, at least get the data. That's how the mine-clearing vehicle was born. The machine was built quickly. They took the chassis of a T-54 tank, 1 VK-1 turbojet engine from a decommissioned MiG-15 instead of 2 like its failed predecessor. Simplified design, minimum modifications, maximum speed of commissioning for testing. The VK-1 turbojet, Thrust, 2,700 kilogram force. Exhaust gas temperature, several hundred degrees. This was the first serial Soviet jet engine, copied from the British Rolls-Royce Nin. It was installed on the MiG-15 and MiG-17 fighters, IL-28 bombers, and Tu-14 torpedo bombers. After being removed from aircraft, the engine served for decades on the ground, clearing airfields, extinguishing burning oil wells, and now they were clearing roads of mines. The nozzle, with a diameter of almost a meter, protrudes above the hull like a gun barrel. The clearing width is 10 to 12 meters, 3 times that of its predecessor. Speed from 1 to 3 kilometers per hour. Operating time 2 hours. Reliability of mine clearing is stated as 99%. Depth up to 20 centimeters, with a ripper up to 50 centimeters. One refueling is enough for 6 kilometers of travel. The crew consists of 2 people, commander and driver mechanic. Junior Sergeant Vladimir Kovyazin was put behind the controls of this monster. A typical Soviet soldier, a tank driver mechanic who entered military history simply because he happened to be at the controls of the most insane machine of the Afghan war. Kovyazin underwent standard training, received his assignment, and drove a ton of steel with a roaring jet engine along a mined road. The machine was loaded onto a transport plane and sent to the mountains. The first launch on Afghan soil. The turbine howled, the sound spread for kilometers, reflected off the rocks, and returned as a greatly amplified echo. The local residents froze. They had heard fighter jets in the sky, but for this howl to come from the ground was impossible. Kovyazin drove the machine onto the road, turned on the systems. A scorching jet of flame hit the road surface. A show began that no one expected. The asphalt exploded in chunks. Gravel flew like shrapnel. The ground rose in a column 20 meters high. Visibility 0. Control was only by instruments, like an airplane in the clouds. The dust was so thick that Kovyazin drove the machine practically blind, relying on the gyro compass. Mujahideen stood on the roadside, watching the roaring monster. A stream of fire from a giant nozzle. The ground explodes in front of the machine. Dust and heat enveloped everything. For them, it was the end of the world. No one had ever seen anything like it. A jet engine is for the sky, for airplanes, but this thing crawls along the ground and burns everything in front of it. Scouts ran to their commanders, panic in the reports, a new Soviet weapon, a thermal cannon on a tank, a flamethrower that could be heard beyond the mountain. It's no wonder that the uneducated partisan scouts initially mistook the giant nozzle of the mine-clearing vehicle for the barrel of a strange cannon and panicked, reporting impending disaster. Western intelligence intercepted the message. Analysts were perplexed. The Russians were testing something, a monster of fiery roads. But what was it? Agents tried to get closer. Most never understood what they saw. Kovyazin confidently conducted the warm-up along the Jalalabad-Asadabad route, literally uncovering the saboteur schemes. When the gas-dynamic jet impacted the road surface with its damaged asphalt pavement, soil and gravel were ejected. All the irregularities were clearly exposed. The crew stripped the camouflage from the mines embedded in the rocky bed. They appeared in view like nuts shelled from their shells. The mines flew away from the pressure of the gases. Some detonated safely from the temperature, far away. Others were simply exposed.
Sappers followed, marking and neutralizing the mines. The strip behind the mine-clearing vehicle looked plowed and scorched, as if after a bombing, but clean. In 2.5 hours of continuous operation, the machine could cover 6 kilometers with a width of 12 meters, a whole highway for the next column. The main result was psychological. The turbine's whine could be heard 3 kilometers away. The militants began to leave their positions in advance. Rumors multiplied. The Russians had created a machine that burns everything alive. It sees through the ground. It is invulnerable. The mere sight of this monster instilled terror. Fear worked more effectively than any weapon. The monster of fiery roads was nicknamed for its menacing appearance. There were attempts to use the machine for other tasks as well.
decontamination of armored vehicles. Substances that destroy poisonous substances were introduced into the gas stream. Drying of runways, roasting of basements with militants. As the military joked, roasting the basements with militants until they were crispy. However, the latter remained a joke. Human rights activists would have screamed too loudly. But the euphoria didn't last long, because behind the impressive spectacle were problems that no one had taken into account on paper, and these problems began to surface with every hour of operation in combat conditions. That very reality that kills any brilliant idea. Specific fuel consumption of the VK1G7 per kilogram of thrust per hour in cruising mode. Let's translate this into human language. At maximum RPM, the engine consumed almost 3 tons of kerosene per hour of operation. The T-72 tank carried 15 tons in its tanks. It was enough for 2.2 hours and 6 kilometers of travel. After that, the vehicle turned into a 40-ton immovable object. Compare this to a regular tank. The T-54, with 700 liters of diesel fuel, could travel 400 kilometers. Warming up required 1.5 tons of kerosene, 6 times more. The difference was 67 times. Every meter of cleared road cost grams of aviation fuel. The project's economics were catastrophic, but fuel consumption turned out to be not the biggest problem. The noise was so loud that even inside the sealed cabin, the crew experienced serious discomfort. A turbojet engine at maximum RPM produces 130 to 140 decibels. This is the pain threshold for the human ear. Kvyazin and the commander worked in headphones, but even that didn't completely help. After 2 hours of continuous work, their heads were splitting, their ears were ringing, and their coordination was impaired. Dust was the third problem. The gas jet lifted tons of soil into the air. A cloud of dust completely enveloped the vehicle. Visibility dropped to 0 not only outside, but also inside. The finest particles penetrated through all the cracks. The air filters became clogged after half an hour of operation. They had to stop, clean them, and continue. The trawling time increased and efficiency decreased. The engine itself worked in hellish conditions. It is designed for flying at altitude, where the air is clean and cold. Here, the VK-1 was sucking in hot, dusty air right near the ground. The temperature of the gases before the turbine reached 987 degrees. Under such conditions, the engine's lifespan melted away before their eyes. The claimed 200 hours of operation turned into 50. Engine replacement became a regular procedure. The trawling speed was from 1 to 3 kilometers per hour, slower than a pedestrian walks. The convoy behind was waiting. The Mujahideen knew where the minesweeper was by the sound. They had time to regroup at a distance of 3 kilometers, take new positions, and prepare an ambush further down the road. The psychological effect only worked the first few times. Then the militants got used to the monster and understood that it was only dangerous in the area where it was operating. The trawling width was 10 to 12 meters. It sounds impressive, but the Afghan mountain roads are narrow, winding, with steep turns. The heating system was only effective on straight sections with a hard surface. On dirt roads, it simply dug into the ground, creating a trench instead of a passage. On turns, the jet of hot air missed the road and hit the rocks. On upsents and descents, efficiency dropped by half. Technical maintenance became a nightmare. The engine required regular inspection. The fuel system was capricious. The gyro compass was knocked off by vibrations. Spare parts were brought from the Soviet Union. Each breakdown meant a week of downtime, and the machine was the only one of its kind. There was neither experience in operation, nor an established repair system, nor trained mechanics, and most importantly, narrow specialization. The heating system only worked on roads with a hard surface.
only for detecting mines, not for destroying them. Sappers still had to follow and disarm the exposed charges. In fact, it turned out to be a chain. The heating system blows away the soil, sappers disarm the mines, and a conventional mine trawl clears the area. 3 stages instead of 1. For comparison, the conventional KMT-6 roller mine trawl, based on the same T-54 tank, did everything in 1 pass. It was blown up by mines. The tracks withstood the blasts, and the rollers could be replaced in half an hour. Fuel consumption was the same as a tank. Speed up to 20 kilometers per hour. Trawling width 6.5 meters. It worked on any roads and off-road. Simpler, cheaper, more effective. After several months of testing in Afghanistan, the verdict was obvious. Yes, the HT tank is impressive. Yes, it creates a powerful psychological effect. Yes, it works technically, but there is no practical sense in it. Too expensive, too complex, too capricious, too narrow specialized. The project was quietly closed. No press releases, no explanations.
One day, the Progrev-T disappeared from the Afghan roads. Where did the monster of fiery roads go? What happened to the only existing cocky? And most importantly, did this whole crazy idea die with it? It turned out, no. Turbojet engines on tracked chassis did not disappear without a trace. They found their place, but not at all where the military tried to use them. The newspaper Son of the Fatherland published an investigation in 1993. Journalists searched for traces of the Progrev-T. They interviewed veterans, checked archives, and visited military equipment depots. The result was only speculation. Perhaps it was lost somewhere in the Afghan gorges. Perhaps it is rusting in the junkyard of an experimental design bureau. There is no precise data. The only copy disappeared without a trace. The documentation is classified, and almost no photographs remain. The story ended where it began, in dust and thunder. But the idea of putting a turbojet engine on a tracked chassis did not die. It simply found a completely different application. 1965, Novosibirsk. The UPO testing station conducts experiments. They take a turbojet engine from a decommissioned fighter jet, put it on a truck, direct the jet stream at a burning tank of petroleum products, and turn it on at full power. The result exceeded expectations. The flames were blown away as if by the wind. The temperature dropped instantly, and the fuel stopped evaporating. The fire was extinguished in minutes, where it would have taken hours with conventional methods. This is how the AGVT gas-water fire extinguishing vehicles were born. The principle is simple, to the point of genius. The turbine creates a stream of superheated gases at near sonic speed. Water is injected into this stream at enormous pressure of 90 liters per K. The water instantly turns into a fine mist. The result is a gas-water mixture, which strikes the fire with tremendous force. The Torzhok plant began production of the AGVT-100 on the ZIL-131 chassis. Then the AGVT-150 appeared on Ural and Kamaz chassis. The machines were distributed to oil fields throughout the Soviet Union, Tyumen, Baku, Mangyshlak, everywhere where fountains of black gold gushed. Extinguishing an oil well fire is a task that is almost impossible with conventional means. It's not just oil that's burning, it's a jet under pressure of tens of atmospheres. The flame is 20 to 30 meters high. The temperature is under 1,000 degrees. The thermal radiation is such that asphalt melts at a distance of 50 meters. Ordinary water is useless here. It evaporates before it reaches the fire. Foam is blown away by the gas pressure. Powder is blown away by the wind. Brute force is needed to physically break up the column of flame. The AGVT approaches as close as possible and activates the irrigation system.
Slit nozzles envelop the machine in a water curtain to protect it from the heat. Then it starts the turbine, first low power, then afterburner. The roar is like a fighter jet taking off. The ground shakes from the vibration. The operator directs the nozzle at the base of the flare, where the oil is just beginning to burn as it emerges from the ground. The gas-water jet strikes this point. The pressure is phenomenal. The jet of water literally cuts the column of fire in half. The upper part of the flame breaks off. The lower part is extinguished by cooling. The fountain continues to gush, but it no longer burns. The method works where everything else is powerless, but it can only be used in critical situations. The AGVT consumes fuel in barrels, requires constant technical maintenance, and costs as much as 3 ordinary fire trucks. But when a well worth billions is burning, the price of the question is irrelevant. 1991 brought the AGVT worldwide fame. Iraq occupied Kuwait. During the retreat, Iraqi sappers blew up 700 oil wells. An ecological apocalypse began. Smoke covered the sky. Oil burned in rivers. The air temperature rose by 10 degrees in a radius of 100 kilometers. An international coalition gathered firefighters from all over the world. Americans, Canadians, British, Chinese, everyone brought their equipment. The Hungarian company MB Drilling built Big Wind, 2 engines from a MiG-21 on a T-34 tank chassis. Soviet specialists brought their AGVTs. The Kharkiv machine based on a ZIL-131 showed itself better than Western counterparts, unpretentious, durable, easy to repair. They offered it $1 million right on the spot. They refused and brought it home. The Kuwaiti fires were extinguished for 8 months. The last well went out in November. The AGVTs coped with a task that was considered impossible. The same technology that failed as a mine trowel saved the oil fields. Did you like it? Click like. Want more stories about crazy military technology? Subscribe. Write in the comments what you want me to cover next. Flying tanks, atomic airplanes, underwater aircraft carriers? There are enough absurd projects to last for years.